We're starting just a little bit late, so we'll try to stay on target and on track. I'm David Mandala. This is Scott Bambro. We're presenting on 96 boards in the course upstream. We have a fair amount of information both relating to 96 boards and mezzanine boards. So with that, I'll get started. We'll talk about the program status first, then get into hardware ecosystem, how we're moving things upstream, and a summary and a question and answer period. Program status right now, the infrastructure is set up for 96 boards. We have a website. We have a source, all the source code is stored at GitHub. We have a bug tracker, forums. We have an area for in the news and snapshots and releases. We will have a blog on the 96boards.org site. That'll be coming soon. So we're, infrastructure-wise, we're in pretty good shape to move forward with the 96 board support in general. With that, we'll move on to the hardware ecosystem. Obviously, we're shipping 2 boards. At the current time, the HiKey and the DragonBoard 410C. The blue DragonBoard is the production model. Some people have seen the red one. Functionally the same, but just a different way of telling whether it was production unit or not. We have several boards in development that have been publicly announced. We have Action's Semi Bubblegum 96, the Freescale IMX6 board, and the AMD EE board. There's others in development that I can't talk about at this point in time, but stay tuned to the website and you'll see them when we can talk about them. Mezzanine boards. There's currently 3 boards at some level of design or production. The 96 boards UART mezzanine board, that's a little board that many of you have seen. I've handed some out here, and I've got some more that will be going out to some of the developers. It's basically a way to get the 2 serial UARTs out in an easy fashion without having to have a very expensive 1.8 volt converter USB cable. Just a word of caution, anybody in this room, if you get one of those and you want to plug it into your 96 board, please be careful that you take the little micro USB and point it off the board, not across the board. If you point it across the board, you will let the magic white smoke out of both devices. Please don't do that. Sensors mezzanine board. I saw a demonstration of that this morning. We will be giving out up to 50 kits for people to develop neat things with it. They actually arrived in volume just a little while ago, so I do have them. It's kind of a fun mezzanine board. It does have level shifters on the board. It does have also the UART output, so you don't have to have both the UART board and this. It's incorporated in it. It is Arduino Uno compatible. So it's kind of a neat thing. If you were in this morning's keynote, you saw a lot of information about that. If you have any questions, feel free to grab me or grab Grant at any point, and we'll be happy to talk about it. I think, Scott, you know a bit about it too, don't you?
A little. Grant's probably the one that knows the most about it.
Yeah. And we have the Grove mezzanine board that's in design at this point. It's not in production. It basically has the same footprint as the 96 board CE spec. On the I/O, it's basically a level shifter board, and it will have Grove connectors. I just put up a picture of the early layout, what it's going to look like, but it's subject to change. It is, as I say, completely in development at this point, but it's designed to really break out the GPIOs and break out the bits from the board and make it easy to use for development purposes. Okay, I'm going to hand off to Scott on how we're achieving better upstream coverage.
All right, so I think the basic thing about 96 boards people want are first and foremost, they want the code upstream, particularly the kernel. A lot of pressure, a lot of interest in having that happen. The other thing that comes up most often is documentation, right? They want a TRM for the socket and the board. In that regard, For the boards that we have, the schematics are available. That's part of the 96 Boards program. They'll always be open source. The layout files, that's up to the manufacturer. But you will always be able to get the schematic for the board. There will be a hardware manual telling you a bit about the board. It'll have different names. You have a hardware manual here and with HiKey. We also have reference manuals for the socks. These are available, and you can download them by going to 96boards.org and going to the product area and grabbing on the downloads and documentation page. There is actually quite a bit of information available. Not everything's available. We do have some problems with third-party IP that we can't release. It's under NDA. We've tried to work on that and get as much documentation out as we can. If there's something that you don't think is available that you think it should be, you should always feel free to send us an email and say, hey, I wish we had this. We might be able to help you, we might not. But we can certainly ask. So probably the biggest thing people are most interested is what's upstream. So I'll talk about the HiKey first, and then I'll talk about the Qualcomm Snapdragon board. And I'll start from the very bottom and work my way up. The bootloaders on the devices. We started off with the HiKey with a proprietary bootloader, mainly because we could get it working fast and get the boards up and running quickly and get them out for the last connect. And then we started a port of ARM-trusted firmware and UEFI. And today, we've actually started to make the change in the snapshots. We've switched them all so that we're actually deprecating the fast boot bootloader. We've moved to the ARM-trusted firmware and UEFI. And that's available now. You can use it, you can boot with it, and we'll shortly do a release with it once we're happy with the quality and work through some of the bugs that we know have found. There were some actually performance issues with flashing that we wanted to get cleaned up before we shipped. They seem to have been solved now. There's still one, I believe, in UEFI. It takes too long to flash a system image. The guys are working on it as fast as they can. There's also a community port. Peter Griffin ported U-Boot to run with ARM-trusted firmware. So instead of UEFI, you can boot up into a U-Boot environment. I've listed here the initial work that he did. He sent upstream. I believe it's been accepted. And there's a set of new changes that he submitted up there. They're still in discussion. With the U-Boot port, I believe the one thing that's left to do is, well, one of the major things he wants to do is switch to a device tree configuration, but he's waiting for the device tree in the kernel to be updated first. For the kernel, our current best enabled kernel at this point, the one that we work with on a regular basis, is 3.18. You'll find that on 96boards.org, GitHub actually, GitHub in the 96boards project. It has power management, it has the display working. We've had to do a lot of work on the display. There's been a bunch of issues with timings and display modes that we've worked through. It's there. I don't think people are keen on the fact that it's 3.18, but it lets you do a lot of things with the HiKey that you normally wouldn't be able to do, and shows what we can do. We have started to do upstreaming for this board. You can see here now that in 4.1 we had some eMMC and the micro SC drivers merged. In 4.2 we're getting closer to with other things. We're starting to merge the device tree. code, thermal support, and CPU freak. One of the things about HiKey is we changed, there's a proprietary binary, it's a MCU binary for power management. It controls the system power. It changed on us and the interface to it changed. So we had to rework ATF and UEFI to work with it. And we would also have had to done the same thing with Fastboot, but we decided to focus on ARM trusted firmware and UEFI so that it would get done. It's done, it's available. With it, we get CPU hot plug now, and some more PSCI features, which is nice. There are plans now for 4.3 to start implementing a stub clock, which uses mailbox features that were implemented to actually work with the new MCU binaries, and that will let us do a lot more with CPU freak, I believe. There was a meeting in Shenzhen last month of a bunch of teams from inside HiSilicon and the landing team, and they basically came to an agreement on resourcing for upstreaming, and they came to an agreement on who was going to do what. HiSilicon plans to do most of the upstreaming for the SOC, and they have a team of, I think, 6 people now working on it full time, and they're planning on doing as much of it as they can as fast as they can. I would say they're planning on it. It'll take to the end of the year, but you'll see more and more go up as these guys work on it. Their plans right now is they'd like to get a certain amount of stuff into 4.4 when the RCs started in the merge window, and they'd like to have those patch sets up and running, or sorry, up and submitted for review before the end of October. This is all HiSilicon, so I can't really promise you anything, but that's what they've indicated to me what they're doing, and they've actually put the people behind it to do the work on it. So I'm reasonably confident that it's going to start to happen, which will make a lot of people happy, I think. One of the other things they want to do is set up CI jobs so they can start testing the topic branches, and that means getting the HiKey working solidly in Lava, which I think we finished. The targeted subsystems, PMIC, regulators, I2C, microSD, CoreSite, DRM. There's a small Bluetooth change. It's just a device tray in the mailbox. The mailbox has already been set up. It's on like version 3 of the patch set. It's under review. Some of the issues that they have, the SMMU and ION enablement, they've made some changes to ARM IP that's in the kernel, and they need to work to merge that support with the existing ARM support. The display on this thing depends heavily on the analog device is 7533. It's an HDMI bridge, and we've had a lot of trouble with it, with timings, but I think we're starting to get a really good handle on this. And that code's about to go upstream. Part of the work on the analog devices part is done by analog devices. We've made some changes to it, and so have the Qualcomm guys. So there's coordination that needs to be done between both those teams and analog devices. I heard last week from Guodong that the TI Wi-Fi module is now working at mainline, which is really nice, because right now the only way we could get it to work was to use an out-of-tree driver, and it's a real pain to build. This will make it a lot easier. Beyond the Go driver, they plan to use reuse an existing driver, and that should be fine, but the PHY driver needs to be completely reworked and implemented. And there's no audio support on HiKey at this point in time. Other software. Upstream-wise, I guess Victor Chong and Jerome, I forget Jerome's last name. He's a Huawei assignee in the security team. They've done a port of Opti, and it's available for the HiKey, and it's in the upstream Opti trees. Right? So it's completely upstream. Some other things that are happening right now, there's a real-time port, Xenomai, that's being worked on by Jorge from LDTS. It's a personal interest of his, and he's been working on it for a month and a half. He's going to upstream that as well. JTAG and OpenOCD. There's been a community effort. Peter Griffin did a bit of work, and someone else in the community has done a bunch of work to get JTAG available and working to some extent on the HiKey. It's an interesting project. It's been a lot of work. They had to figure out how to solder the board and get the parts, and they've done a lot of hard work and debugging. Docker's been reported to be working now on the HiKey, and the last I heard from Fathy was that the changes have been made in the Debian root file system, so it shouldn't require any more changes. You can just download a snapshot and it'll work. The last thing I'll mention is that there's been in the premium services team, they've been trying to learn a bit more and get some training material together on EAS, and they're doing a port of it to the HiKey to see, to test their knowledge and to learn a little bit more about it. Switching to the DragonBoard, we'll talk about the bootloaders. The first stage bootloaders in the DragonBoard, they're proprietary, and at EL1 we switched to using an open source bootloader called Little Kernel. I know of no known plans to port any other bootloaders at this time. The last I heard that to port ARM trusted firmware, we need some patches to the proprietary bootloaders. The kernel's basically mainline plus some patches. The Qualcomm landing team, and Qualcomm in particular, spent a great deal of effort and worked very, very hard at upstreaming the patches for this board. To date, that means that you basically run Ubuntu from our stock Ubuntu image with a version 4.2 kernel, plus a set of patches that represent the delta between what needs to go upstream. It's very small, and it's quite amazing. It's the first board I've ever seen with this level of support upstream. If I go through this, they've been doing a bunch of stuff. They've done basic support for the SOC version 4.1, DRM in version 4.2. They did the PMIC regulators, audio. One of the things that's of note is they removed about 11,000 lines of code. That's a significant chunk of code that no longer needs to be maintained. Let's see. And in the current RCs, they've added SD card support, USB, LEDs. The display has support for most of the common resolutions now. They've had similar trouble that we've had with the HiKey, with timings. They've been solved, to my knowledge. One of the big things that went up is the RPM support. It's their Cortex-M companion for power management. That was gating a lot of work. It needs to go up now. So once that's up there, we can start shipping up more, is what I'm told. And what else? So this is basically what's left at this point. These are features that are in discussion on the mailing list. They expect to go upstream soon, get accepted, I think is the way I would put it. There's some display changes, so they have support for all resolutions. USB host on the go. CPU freak, part of that I think is due to the acceptance of RPM. These are no longer gated by that. Probably some of the thermal and cooling stuff is the same. RPM clocks is another one. This work, you can talk to Nicholas Deschen, some of the Qualcomm guys that worked on this, if you want more information about what's exactly needs to go upstream. Part of the issues, I think, with the upstream kernel at this point, there's no PSCI support in mainline for this board and SOC. So only one A53 is booting at this point. There's a clock driver that's missing. We require a custom IOMU driver because of lack of secure SMU support. The ADV57533 and the video for Linux stuff needs to be cleaned up and submitted. It's probably more of a case of cleaning up the kernel and then cleaning up GStreamer and working with the GPU. The LAN driver is based on an upstream port for this for the LAN module that's on this. It's actually part of the SOC. I don't believe it's actually Qualcomm supported, but it's an open source implementation, community implementation. I think this one's yours, isn't it? Yeah.
All right, so one of the issues with the 96 boards, we've got everything electrically on all the pins. It's all standardized, and that's really neat. But obviously, because it's using different SOCs, you enable the GPIOs differently, which makes it hard to run the same binary application on different boards. You won't necessarily turn on the GPIOs. You've got to change the numbers. So we've done a little work with that. Right now, there's a 96 boards GPIO library. It's under LGPL v21 license. It's a prototype library. It unifies the GPIO access across the 96 boards on the low-speed header. It has Python bindings, and we're going to be adding Java and Perl and other bindings as well, so that you can basically open up GPIO based on the pin number of the low-speed connector, and just say, I want this pin active, and it'll just do it. And it's on exit, it just closes out the library. You don't even need to clean up after yourself. It'll take care of that. Now, we've also been in touch. There's another library out there called libsoc. That's also under LGBL v2.1. It's been around for about 2 years. The gent's done a really nice job on that library, but it doesn't really unify the 96 boards GPIO issues. However, we've been in touch with him, gotten a great response, and if we work within the constraints that he's asked us to work with, he will take all GPIO patches that we put in for 96 boards and incorporate it. Basically, he uses AutoConf, and as long as we set it up so that you make a call with AutoConf for 96 board support, and then all of our patches go in place, he'll accept that. So that library will give you GPIO support, I2C, and a few other things. So it's a pretty nice library. What it does not currently have is bindings for Python, Java, Perl, et cetera, and we'll work on that too. So that's kind of where we're at with that. I think it does help solve some of the issues. And we're at the summary.
So, I mean, we've got 2 boards available, more announced, several more on the way that we can't really talk about. We have the UART Mezzanine Board. It solves a big problem we had with accessing the debug ports and cables, expensive cables. I think it's exciting that we've got the new Arduino Grove sensors board. The schematics are available for the 96 boards, all of them. And I believe Grant told me the schematics for the UART mezzanine are available on GitHub. And I think the plan is for the sensors to be available as well too? Yeah, already? So you can get, I think you can get everything for those last two boards, right, including the layouts,
Yes.
right?
Yeah.
Yeah. So I mean,
There is going to be, there will be a few changes from the first version. There'll be a new version shortly. So.
Yeah, talking to Grant this morning, there'll be some improvements, some minor wiring changes that will make it easier to use. And that should go really, really fast and then be available. According to the grant, likely it'll be available by November at the latest. So that's really exciting. It's going to let a lot of exciting demos and testing be done. So can't hardly wait for that.
was it? Yeah, so as far as the software ecosystem things, I think we should start to see significantly more code going upstream by the end of the year. That's the plans that we have at the moment. If I look at HiKey, we've got end-to-end software support, open source, bootloader and kernel, open source operating systems. The only thing that's not open source on this board is the GPU software, the graphics. The DragonBoard, same idea. The only part that's not is the first stage bootloaders. On the DragonBoard, the GPU is all open source. And we can blame Rob for that right there. Or thank Rob for that, actually, I would say. It's very unusual to see this. And I think Qualcomm has actually gone a long way to support this. And I think they should be commended for that. And I'd like to thank you guys. Again, the board and SOC documentation are available. I've had several conversations, and a lot of people don't seem to know that the documentation is available on 96 boards. I'd encourage you to go look at it and have a look at what's available. I think it's more than people believe is available. And if there's not, please comment, send us a note.
Even to the point, if you feel like there's something confusing, you can't find it, and you hunt for it for a while, and then you find it and think, wow, it's in a really lousy space, comment, let us know about it. I can't get it fixed if we don't know about it. We think it's pretty good, but that doesn't mean it actually is until it works for other people.
Yeah.
All right, comments, thoughts? Anybody?
Any questions?
So the plans moving forward are great. It's good to see that there is actually a decent amount of movement to try and get more stuff upstream in mainline on all aspects. My question is, why wasn't this part of the initial plan? So instead of pushing the boards out in February, when the software story really wasn't in place, actually doing what the incumbent architecture does, get the stuff upstream, and then the hardware comes out and your stuff just works. Working with some partners where we've been seeding 96 boards, they've hit major issues, big blockers, because upstream's not there. And that's caused major issues. And it also reflects negatively somewhat on the whole initiative, which is something that I'd rather not see happen.
Well, I think at the very beginning, we wanted to actually introduce 96 boards and do it at the last Connect. Part of the problem we had has been actually doing basic board bring up and enablement of the SOC and the operating system at the same time, it was a bit of a rush. The board was delayed, so we didn't actually get to start to work on it when we thought we would. The other thing is that I think with HiKey, we kind of blazed the trail for 96 boards altogether. We sort of had to define everything, what we were going to do, what was the software load that was going to be shipped with it, how we were going to ship it, solve all the licensing issues, like say with Mali, solve licensing issues with proprietary binaries, the MCU image, that kind of thing. Make sure we had the rights to distribute them. There's a lot of little things that crop in there, and it was a resourcing issue. At this point in time, there were 3 guys working on this with help from Huawei. They chose to stick with a 318 kernel. It was the one we knew was closest to working. We did start with an early development board that Android had been working on with 318, and actually 314 or 3.10 actually. And we moved to 318 at the time. Wasn't so much a plan, it was a case of with necessity. We didn't have the time to actually do enablement and do
Scott, can I say a word?
no, I'm not going to let you talk.
Well, my microphone doesn't.
Oh, you
no,
got
it
one,
does.
all right.
Just come up. So look, totally valid question, totally valid points. Ideally, we would have everything upstream, release a product, and the world would be a wonderful place. The ARM ecosystem isn't quite that good at that yet, and we had to make a choice. And our priority was to get boards into the hands of Linaro developers. And interestingly, we handed out a lot of boards at Linaro Connect in February, and a lot of those have been used to do some pretty amazing things, including work on some of these outside projects, getting code upstream into different projects since then. Only now are we actually getting the manufacturing channels in place to actually, and having enough boards out there that the people who want these boards, and there are a lot of people who want them, can get them. And so it's sort of been slightly fortunate and unfortunate in other ways that both from Qualcomm and HiSilicon, I think in Q4 you're going to start to see boards coming out and better support upstream. If we'd waited, we would be still 6 months away. And this is, the feedback that we've had is about, we want to see more support for this kind of board upstream. Well, that's very difficult when you start from a mobile chip that's been sitting in a mobile phone that's a dedicated embedded product. It's been difficult for all the companies involved, but I think everybody realizes this is worth the pain. And we will get better and better at this. Not we, Linaro, but we as a community. We, as when we bring out boards for developers, the universities, the community can use them much faster and much more effectively and get you more visibility into the market the closer you are to upstream. And the real vision of this is that this actually goes back into product teams in these companies and actually benefits the companies building these boards because they actually work closer to upstream and find their own internal costs are reduced and they can focus more of their effort on their own value add. It's a journey, and the fact that you can now get a $75 64-bit multi-core board is in itself a huge achievement. Software always takes longer than hardware. Nobody believes that, but it's true.
Yeah, I'll echo, I'm really glad personally that we got the boards out there, because if you got the hardware, the software will follow. If you don't have the hardware out there, it's really hard to work on the software, and that was a lot of problem they had. Do I want everything upstream? Yeah, and I think now that there's more boards, it'll get better and better. Somebody else,
Thank you. So I'm not that annoyed by the delay that Andrew mentioned about the HiKey board. I'm much more worried by the fragmentation of the ecosystem we're already seeing with the DragonBoard, which makes sure that none of the standards that we've chosen for ARMv8 are followed. No PSCI, new SMP ops are not in mainline, can hardly be supported in mainline. basically we end up with something that is just a repeat of the ARM v7 nightmare. And that's not really what I was expecting from Linaro. So that's, for me, that's what the real problem is.
Was there actually a question in that?
Okay, so listen, there are a large number of members of the community, the maker community, universities, applications for these products that actually are not working on the bootloader and they're not working in PSCI, right? I agree that 3-4 years ago, it would have been great if those standards had been published, they'd been open source, there'd been a reference implementation, everybody could have implemented them. But here we are, we're 3 years into products based on 64-bit ARM technology. The good news is that the enterprise boards, for example, they have to be upstream straight away when they come out, because otherwise there won't be any software for them at all. The distros won't work. So you'll see in the enterprise boards a completely different approach, but that's because they weren't starting from a bunch of legacy, from a legacy situation. Even in the 64-bit world, there's a legacy situation because of the mobile segment and where these products are coming from. And if we're not careful, it's going to get really bad and we're going to have to clean up the mess again, especially in embedded. But everybody who's involved in this project understands that we want to get to an upstream implementation as fast as possible. And companies like Qualcomm with DragonBoard and HiKey and HiSilicon with HiKey and every other SoC vendor that's out there in the mobile phone space and the embedded space has their own proprietary code that is costing them a lot of money to maintain and continue building. It takes time to move to new standards. And I actually think that the DragonBoard is a fantastic testament to the need for a common standard across multiple vendors, and that, okay, if you want to work on an open source bootloader from EL3, from the SoC coming out of reset, it won't work yet on DragonBoard, but maybe it will work on the next one, or the next one, because when you can start with some code that's already there, you can work much faster than having to start from scratch when you've just got a legacy piece of code. And there will be many, many people who can use these boards and get access to 64-bit technology at a really low price, who are working in, as I say, education, the maker community, the kernel, the user space, for whom either board or any of these boards is very applicable. So think of it from the other side. This isn't as easy as it sounds. It's like I said this morning. It's relatively easy to say you are going to save money, you are going to benefit from working in the upstream way in the open source community. Unless you've been doing it for a long time, it's very hard to instantly switch your organization to doing it. There's a lot of inertial resistance in any company, and even we find this. I mean, in doing the HiKey board, because HiSilicon took some of the work on in the landing team, we took on some of it, and as Scott said, we couldn't have got a product even to the developers' hands if we'd waited until we could get it all upstream. And we just made the decision that better to get something out and work on improving it than just have nothing there and still, arm shut your ears, still have $6,000 Juno boards as the only way of delivering 64-bit hardware. We made a choice.
Yeah, I also think the work we talk about here is basically foundational. And I don't want to see something that's setting the groundwork for other people to work with these boards delay that activity, right?
Demand is exceeding supply. That's a good sign.
Demand is exceeding by a long shot right now. More questions. We're almost out of time, and I do want to get any more questions out there. And I'm interested also specifically, I'll shortcut one bit. If you have comments on mezzanine boards, see me after. I'm happy to take all comments. I'd like to know.
So is there any plan for EL2 or EL3 on DragonBoard? As currently you can't use any virtualization on the DragonBoard.
I'm not sure I understand.
I don't have an answer to that. I'll have to find out from Qualcomm. Any other questions?
So what exactly it is and or was our goal with 96 boards, because as it stands at the moment, I mean, I've got friends who've tried HiKeys, and it's embarrassing to answer questions about them.
I'm going to let you handle that one.
At the moment, it looks like we're following exactly the same mistakes that we were set up to try and encourage members not to make. And we've got a load of boards out there that just don't work very well with no upstream support. Why? It seems like we're just trying to drag the Linaro reputation through the mud.
Yeah, I'm going to have to take issue with that. I mean, look at the upstream support for the DragonBoard. How can you say there's no upstream support? You're exaggerating.
It moves around this, but there's no SD card support, there's no eMMC 4.3 RC1. It's not there.
And only one core works.
Yeah.
Yeah. No, look, the world, however perfect you would like it to be, it is not perfect. This is a really hard problem to solve. And yes, the members could have said, we're going to put a team of 20 or 50 engineers onto solving this problem in 3 months. But that's a very expensive resource to commit. And to be honest, if you think about the structure of Linaro, the only company that can actually work on a dedicated board is that company themselves. We are a shared engineering resource. For example, it wouldn't be reasonable to ask HiSilicon to work on Qualcomm's boards any more than it would be to do original engineering work for one of your competitors. It's just, that's not what we're talking about here. What we're trying to do is, it isn't even a technical problem. This is actually a social and engineering problem of how do we show the community and the companies involved that they're going to get benefits from changing the way they work. And when you think about where these chips are coming from, they're coming from top secret mobile phone implementations where nobody ever has to worry about upstreaming. Now, our view that, as an open source community, is that that's a very expensive way of doing software development. But that's the way it's been done for the last 20 years, right? And it takes time to change that. Now, what was our goal in getting 96 boards out? It was to change that. Can we change it without, there's a chicken and egg here. Until you can see the scale of the problem and see the benefits of improving it, it's going to take time. And the other comment I'd make is that the fact that we're having this conversation has achieved one of the main goals of 96 boards, which was to get the hardware out to enable people to start working on the problem, the entire community to start working on the problem, right? And to answer your question about what were the goals, the original goals, and the reason that Linaro got very frustrated was that the only way we could work on 64-bit technology was behind closed doors with members. Because when SoC vendors bring up SoCs, they have these big development boards that are very expensive, right? They don't build very many of them because they're horrendously expensive to build and you can't maintain them. They're great big boards with all sorts of interfaces so you can put scopes and everything on them. And they're out of reach to put into every software developer's hands. And we were still working on emulators. And you think working on HiKey or DragonBoard is hard. Let me send you back to QEMU and working on emulators, right? It was about getting hardware into the community's hands, into Linaro developers and then the wider community. And once you get the hardware out there, as Scott and David said, the software will follow. We've got a lot to do. What's encouraging me is that there's a lot of communities who are really interested in taking these boards and using them in fields that we haven't thought about, in education, in robotics. Think of this as a grown-up Raspberry Pi, right? If a Raspberry Pi introduces your kids to computing, these boards are for actually doing serious things. They're for people doing research. They're for prototyping enterprise applications. They're for doing things that you and we haven't thought of yet. And actually getting that done, even the fact that these are not perfect from a software point of view, has made a huge change. I actually think that you'll find that in a year's time when we have this conversation, one, you'll be praising how much upstream support these boards all do have, and secondly, you'll really see the impact of what we've done here. This is just the beginning. I'm not going to answer any more questions.
Okay, that's fair.
Can we have both points? Because I understand your point, George.
priorities, right? The guys are working on things, they're fixing bugs.
But
Trying to make
we're
sure
not,
it goes-
we're not talking about massive development efforts here.
You're missing the point, right? There's a lot of detail and debugging, things that have gone on, right? And it's very hard to actually switch back and forth between upstreaming and fixing bugs. Sorry, I think you're wrong.
All right,
I've been doing this for a long time. It doesn't always work.
Both are needed. Both are needed. And you need, historically, you've needed two teams to do this. In most companies, there's a completely separate team that isn't bound to product schedules that does upstreaming. But that's not the way to do it, right? If you can do it as you go along, as you say, it's actually not that hard. It's changing your business practices. And yeah, we probably didn't eat our own dog food as well as we could have. But that's why you're here, to tell us, particularly because you're inside Linaro anyway as maintainers, and say, guys, you're doing this the wrong way, and we've got that message. But if you think it's hard for Linaro to do it, because we've got deadlines, we need to get this stuff out, we want to get the community enabled, think how hard it is for other companies to do it. And we'll get better, I promise. It's a commitment. But I keep saying this, and we keep making incremental improvements, and you keep pushing us more. We should. We will get better.
all right. Thanks, everyone, for coming. We are out of time, so. It was a very good discussion. I look forward to hallway discussions continuing. If you have more questions, we'll try to get them answered. Thank you for coming.